Well, welcome to the Headless DAM with Cloudinary Bootcamp course, lesson number 7. Gosh, so many lessons we got going on here. An introduction to 3D model formats. Today, presented by Naveen Prasanna. He's the Director of Product Management at Cloudinary. If you want to learn more about him, just watch the interview I did with him. A really great interview. You can find it in the introduction section of this course, of course, on headlesscreator.com. Now, with that said, let's go ahead and bring on Naveen. Naveen, welcome. Glad to have you here. Again, for those of you watching live, in the chat, put any questions and I'll ask Naveen. But Naveen, it's all yours, sir.
Thank you, Marcelo, and hello, everybody. Great to be here. I'm going to talk about 3D formats and kind of demystify that a little bit, hopefully, and then we will talk about what formats are interesting, keeping the future in mind. And what you see on the screen is a 3D wireframe for a Porsche. So how does this work, and what's happening behind the scenes? So let's dive right into it. Um, just a little bit of history, because 3D and 3D modeling has existed for a very long time. So the very first 3D kind of a topic came up in manufacturing back in the 60s, if you can believe it. Well, actually, some say that it goes even further, before the 1960s, where people started to kind of figure out how they could, do computer-aided design, CAD, mainly for manufacturing. And then in the 70s, it started, catching more force. Universities started to research this space. There's a very famous thing that came out of Utah where they did solid 3D modeling with the teacup, and that is a very iconic, image, if you may, in the 3D space. And then, but still, hardware and software were not as powerful. And then in the 80s, with the advent of PCs, CAD software started becoming more and more prominent, and so 3D modeling grew. AutoCAD was actually started back then, and they're still around, and pretty popular 3D modeling software to this date. And this is where file formats and 3D format starts getting to be more interesting, because a lot of people using it. So they, at that point in time, they started figuring out what these file formats would be. So people could exchange the 3D models and kind of work on it. And then the 90s, more hardware, it becomes a little bit more mainstream. And then that is when, the standardization of 3D file formats started, because not just AutoCAD, many other modeling software out there, and you had to exchange what you did. And think about it like, I have a text document or a Word document, and I need to be able to send it to somebody, and they need to be able to open it and read it. Right about this time, tools other than the proprietary tools started coming out. And interestingly enough, Blender, which is used to this day, was created in the 1990s. Now, fast forwarding to the present, 2000 onwards, 2008, 2010, mobile phones, especially the ones that we're used to, iPhone, Android, iOS and Android, I should say, started becoming more popular. And then this is where it started becoming, 3D started to be more accessible, with better hardware and on your devices, and, better networks. And this is where the next kind of shift or move in formats, happened. So people started thinking about, a 3D format for the internet, that could be streamed, if you think about it that way. And that is where the GLTF spec was created. So GL stands for WebGL, and TF there is transmission format. So this happened, I would say about 2008 or 2010, and that is where we are now. And here's where the space is kind of moving into. So before we start getting into specific formats and what's in it, and what happens behind the scenes, let's kind of understand what is a 3D model. What you're seeing on the screen up here is a 3D model for a gearbox, which this is an open source thing that has been put out by Chronos.org. And in the 3D space, you'll hear a lot about Chronos. So this is what the model looks like, at the end of the day when you're finished, creating it and working with it. But let's see what's happening behind the scenes, because it's very important to kind of understand this, while we, get into the different formats and the pros and cons. So the first thing that you need to do when you're creating a 3D model is to capture the geometry, the actual the actual surface, of the object that you're trying to model in any software that you might be using. And so it's you'll hear the word mesh quite a bit. So a mesh is like the skeleton, let's say, of the object that you're trying to model, and it's pretty much going back to what we said earlier in the 60s and so on. It's pretty much a mathematical representation of your model. And the way it's done is through breaking up a large surface into very small pieces. Think about these are called polygons, and stitching together polygons with each other to kind of give you the the model, the area, the surface that you're trying to model. And if you can imagine a circle and you divide that circle into 8 pieces with like straight lines, you'll see that they're all going to be jagged. Now, if you want to make it smoother, you'll divide that circle into 16, 32, whatever number of smaller sections. So it starts smoothing out. And that is what happens with a mesh. More polygons get created, depending on, how accurate you want your model to represent your physical object. And, all this is really data that's being captured in some kind of a format, which tells your modeling software or viewers of the model what to render on the screen. And the larger the number of polygons, the more rich the mesh is, the larger your file size becomes. And one thing I would also try and add here is you can, and a lot of people actually do it by hand, but typically you use some scanners, which, you have LiDAR scanners and things like that, where you could put an object on a rotating table and, scan, all around it to get that initial information that you want, and then you can go and, correct things and make it richer. But so the mesh is the foundation, if you may, of what goes on in a 3D model. And then you have the mesh, and that's great. But you also need to think about how does it look. For example, if I have a mesh, for a metallic part, and if I want to kind of show it on screen, and this becomes very important when you're not, let's say, working with like manufacturing metallic parts, but let's say you're actually creating an avatar or a character, and you want to get a feel for what that person or that object kind of looks like. And this is where textures come in. So my example for textures is let's say you want to show something that is made out of leather, let's say, right? It is not hard metallic. It has like contours. It has a little bit of a look and feel that is different from a metal, and the texture is a way for you to describe it. So in your 3D models, you might even have like UV maps which kind of show you contours, and you'll see this heavily used in movies, for example, where or even games where things have to look very realistic. So you have a mesh, and the mesh has a texture on top of it. Now, so what happens next is, so you have the texture, but you might have to give it a color. You might have to show how how that color kind of reacts or works with light and the hues, and is it shiny, not shiny. And that is where all the visual properties that you want to give to that particular piece or that particular part of the model that you're creating is provided by what is called a material. And again, these are all representations of colors and things like that that are captured inside a 3D model. In this example, if what I'm showing in this example is, it is this the right hand side part of the the model that was being created got a different color here, and this is provided by the material. Now you can change colors and you can do a lot of different things to give it a different material or a different kind of visual representation. And then so you have everything kind of being set up right now, and then finally you need to show how this model might look in real life, or when the light falls on it, right? And that is where shaders come into play, and you'll see this being defined in almost every model, unless maybe you're using it for, say, 3D printing or something like that, where it might not it might not be important. But if I have this model, and if I know that there's going to be a light source, what are the how does this model react to light, and what about shadows, right? I mean, you could have a light source at a particular angle and then be able to show shadows, right? So this is what a shader does. So in essence, these are the foundational kind of blocks of any 3D model. So we talked about the mesh, we talked about the texture, we talked about the material and the shader, and then you could assume that you're doing more with this. You could also have animations. So I'm sure a lot of you have seen that 3D models that maybe it's a figure that moves around, and being able to capture that animation, the physics, and the movement is something which is again possible. And we talked about light, but there's also the concept of a camera. So if how does this particular model look like if I were to see it from some vantage point and take a picture? So that's what the camera kind of pretty much does. So this is everything that goes into a model, right?
Real quick, so regarding animations, we always think of, like Pixar, right? 3D models in movie animations. But there's also animations in manufacturing, right? Of parts, of gears. You want to see how is that gear, let's say you're designing in 3D, relate to another gear? Does it fit properly? Does it, right? Would that be considered part of that as well?
Absolutely. Spot on. And again, given the complexities of what that movement and motion looks like,
Right.
in the case of the gear, you could probably take those two. By the way, a model can have different meshes and
Right.
those properties defined, and so you can show animation in terms of how one interacts with the other. When it comes to movies, it gets a lot more sophisticated, and I'm pretty sure we've all seen these little kind of footages where
The
somebody is actually
layers
acting
coming.
out this
Right.
the scene. They're moving around, and then everything, it's all your CGI kind of comes on top of it
Yeah.
to give those textures, the textures, and all of that, the stuff that goes on to that person. And yeah, that is exactly how it is done. In that case, they're going to be combining those two parts together.
And one last
Totally.
thing, also, you need a pretty powerful computer, right? You need a GPU to run this kind of stuff, or at least to create it.
Yeah, you need. It all boils down to the resolution that you want. I mean, think about it as I have a camera, and
Right.
let's say I want to shoot video at 8K
Mm-hmm.
or something like that, right? And so
Versus
you do have
720p, right?
versus 720p, right? So you just need a much better device to
Right.
be able to do that. Absolutely, it's on along the same lines. And that's an interesting thing here. You will talk about it in a second. Some of the work that Pixar, for example, did with all their movies, it resulted in they had to build out their own
Right.
rigs, if you may, right? Compute and so on, and they in fact ended up creating a format which, as we'll see, was used by Apple or is being used by Apple. So yeah, there's a lot of stuff that comes from movies here.
Well, I'll let you continue on that so we can find out about that format.
Awesome. Great. So this is everything that goes into, not everything, there are a lot more that can happen inside a 3D model, but these are the basics, right? So with that, kind of a background there, we'll kind of get into the formats. So if you think about these meshes and these textures, materials, all of that needs to be saved in some way, right? So if you can imagine there is somebody who's using a tool, I was actually going to use Blender for this presentation today. That's one of the popular 3D modeling tools out there. I decided not to because it could crash and not look quite good in a presentation like this. But let's say you're using some tool like that, and you're doing all this the modeling, right? You're describing your model and fine tuning it, giving it the texture, the material, all of that stuff, animation even, and you save it. Now, what happens typically is every the so there are models that end up becoming the file formats for your 3D model could end up becoming proprietary. So meaning it is only you need that particular modeling kind of a program to actually open that file and that model and work on it and save it and things like that. And there is a place in the industry and in your production side of the workflow for proprietary models, because depending on, for example, AutoCAD might allow you to do a lot of more advanced interesting things, and so they need a way to capture all of that stuff. And so you have this, and then on the other end of the spectrum, you want to be able to share this. For example, I want to be able to see it on my phone, and I can't quite take a AutoCAD, like a DWG kind of a file, and see it on my phone. So you have proprietary models and you have what are called open or neutral models. So let's get into that a little bit. Lot of work gets done in tools like AutoCAD and Blender. I mentioned Blender, and these are just the two that I've put up on the screen here. There are many apps and programs out there that people use. And so you start with a proprietary model most of the times, and then you need to eventually move from that proprietary model to something that is more open. And again, as we discussed earlier, 3D has been around for a very long time. So there are a lot of changes that have happened over time in terms of the file formats and the model formats. So you have the proprietary ones, and then you have in terms of the neutral or the open ones. It first started off with, and it might not be chronologically correct, but generally speaking, there is a popular format called FBX, and the way this started being the way it got created was you had people that were using AutoCAD for, let's say, their drawings, and they had to share it with I don't know, a manufacturer or somebody that had to kind of put it in a robotics kind of a software to do things. And so that interchange, they needed an interchange format, and which is where FBX came along. And there's a tool called Maya that is used to create FBX files out of AutoCAD drawings, if you may, or models, if you may. And then FBX started becoming a format that could be shared and that could be used between programs. And to this day, it's used, especially when you look at animations and games and things like that. This is a very popular format. And then you have you might typically come across another such format called OBJ. Now, it is it's a very easy to understand format, and we'll see that in a second why. And it's widely supported by a lot of different tools. But given the wide support that you see with the tools, you also can do a few things within, like an OBJ. For example, you can do animations, and there are reasons why that happens. And then we talked a little bit earlier about these web formats. GLTF, GLB are the ones that are quite popular. And this was something which was created keeping the internet, keeping all kinds of devices in mind. And as we'll see in a second, GLTF is a format that is pretty much mostly, it's JSON behind the scenes, and you can do some very interesting things here. I'll show a quick demo of some of those things. And then we talked moments ago about Pixar and everything that Pixar did, and how that resulted in its own kind of format. And that brings us to what you see on Apple devices today on iOS. And Apple had deep connections with Pixar, and this is called the USDZ or the USD format. So here are some ideas or some examples of what the different formats are. But let me show you real quick what's actually being captured in these scenes, in these in these models. So what you're seeing here is a few examples that of 3D action 3D models that I have here, and I just wanted to kind of uh, show you what's actually inside the file, just to kind of give you an idea of what it looks like if you opened it up. I'll start with FBX. So this is something which I'm just going to open it, and you'll never do this or actually change it. So I'm just viewing it. So this was a model that came out a couple of years ago. Somebody trying to kind of create a model for coronavirus. But something that I was able to pick up easily off the internet. So I'll just show this to you. So this is an FBX, and FBX is what is called a binary format. So if you open this file up, this is what you see. It's binary, and I'm using a text editor, so I won't be, it doesn't know what to do with it. But the idea here is, you have everything that you need for that particular 3D model. We talked about the meshes, we talked about material, all of that stuff. All that got when you model it inside the tool, in this case it looks like it was Blender, all of that stuff was saved by Blender in a binary format, and this is what it looks like when you open this up. And of course you have readers, you have other tools that can understand this model. It's a little bit of a standard, and you can transport all the data that was in your model that you put into it. All those principles that we talked about can then be used by somebody else. So that was an FBX. And then I also talked about OBJs and why OBJ is an interesting one. So let me open this up and you'll see what happens behind the scenes here. But here, that OBJ, I can read. It's ASCII. It is text, and you can see what's happening here. They're describing coordinates. They're describing different. Looks like this is one mesh, and its coordinates and how it's supposed to work. All of that stuff, and you can read this. So anybody can read this. But once again, given that it's ASCII, if I want to do something more complicated like animations and things like that, this is not going to be, a great format to use. Now, moving on to the more sophisticated, I wouldn't say sophisticated, but I would say the more recent ones. So we talked about GLTF, and we talked about GLB as one of the upcoming kind of formats. So what you'll if I show you what a GLTF looks like, this is very familiar. It's JSON. So everything that you put into the model is captured as a JSON file. This is what a lot of us use when we're creating applications. It could be a Node.js app, whatever, right? So it's all JSON, and it's easy for you for anybody to read this, or any program to read this. And another cool thing with GLTF is, let's say we talked about textures. Now let's say your texture is actually, and textures are bitmaps. So let's say you want to say that you have a particular texture and it's living somewhere on the internet, literally a URL. This format allows you to define it that way, where you can kind of load in things from outside and bring it into the model. Whereas the binary models that we saw just a minute ago, if you had a bitmap, that bitmap and its binary representation of that bitmap had to be stored and saved inside the model. So that's a big difference. One last one I wanted to show you here was, so that was a GLTF. It is text. Sure, you can compress it and then make it smaller. But then there is a version of the GLTF which is called the GLB, and this is the model that I used to take some of the pictures that I showed you earlier about. how a mesh looks like, and textures and things like that. So I'm just going to open the GLB version of it, and you'll see that it's again back to binary. And the idea here is, uh, if you want to package everything that was defined in a GLTF, where, like I said, you could have an image, a PNG or a JPEG, a bitmap that is somewhere else, but you wanted to kind of put everything together and then use it, you could go from a GLTF to a GLB. Now the interesting thing here is, the tools that you have out there today allows these tools allow you to go from one model to the other, where possible. So for example, I could very easily go from a GLTF to a GLB, right? um, Likewise, I could go from an FBX to a GLTF, and so these open or neutral formats are very exciting, for that reason. One final thing about formats, perhaps, there is what we said earlier, the Apple formats, the USDZ and USB. So USD, sorry. So what happens? Why does that format become important? So today, if you're on an iPhone and you want to display a 3D model, or if you want to do things like AR kind of experiences with your 3D models, the model of choice for Apple, if you look at ARKit and all underlying kind of foundational stuff that happens in iOS, their choice of that format was USDZ. And actually, it's USD, which is the larger spec, and USDZ, which is the kind of compressed spec for mobile, which is what is used when you're looking at like a AR kind of an experience. And so those are the want to give you a general sense of what those different model types are. In terms of one thing I wanted to show you here, and you'll see why GLTF or these open formats are powerful. And for that, let me kind of switch over to the screen here. What you're looking at here is the Cloudinary DAM. And if you've seen some of the earlier courses, you probably heard a little bit about the DAM and what you could do with it. So inside the Cloudinary DAM, one of the cool things is you can actually work with 3D models. So I'm going to go and look at this shoe here, which is behind the scenes. It's a 3D model, and as you can see here, it's a GLB. So I'm going to open this up through our 3D model configurator. Let's give it a second. So what I want to show you here are a couple of things. One, I mentioned that these models are an open format. So here's an app that we built using other tools. We'll talk about it in a second, to display a 3D model here on my screen. But the interesting thing here, again, going back into formats and what happens behind the scenes is, given that a GLB or GLTF can have, in terms of its spec, you can swap in or out different things. So you start with a model, and I can swap in or out little pieces of that model and of what was described in that model quite easily. So the example I'm going to show you here is, imagine that I had a model for this shoe built. So the mesh is the same right now. And then I had a texture, and then I had a material. So what I'm going to try to do here is go and change the texture for the skin of the shoe, which was defined as a material. So what we've done here is, here's the mesh for the shoe, and here are all the different, we call them variants here, but behind the scenes, what's happening is we are changing the texture files. So if I go and look at this new color that let's say wanted to kind of give that particular shoe, I went and chose a texture. And as I said, maybe mentioned it earlier, it's a bitmap. So here's the bitmap that I want to use for that particular color. And what you see here is, behind the scenes, we've gone into the model, we've changed the texture for that particular mesh that represented the shoe, and here you have a different color, right? But I didn't actually go and create a new model for this, or even change the model definition in any way. So and then you can imagine, I can do very interesting things. I have a lot of these different colors that I can now define, and all working off of that one individual model. I didn't have to create the 4 different models for 4 different colors. So this is one example. The other one, and we talked about how models could become very large. Um, uh, as you make it richer, as the mesh becomes richer. Now, if I had to take this and send it to somebody, or somebody's viewing it on their app, or on the browser, or maybe it's in a game, and you want this thing to load very fast, right? We don't want to be waiting for a very long time. So just to give you an example of what's happening here. So this original model, where we haven't done anything, was came in at about close to 7 megabytes. And by the way, this is actually not a huge model if you think about it. You can see very rich models where you can have upwards of 500,000 polygons. This is what it's showing here. These are the number of polygons that went into creating the mesh here. But you can have very, very large models. Now, what we've done here is on this side, you see that we've actually reduced the size of the model. We kind of brought this triangle count by almost half, I would say. For that one mesh, there's only one mesh in this model, and so it's a 80% optimization. Now, how did this happen, right? So if we go back to what goes into a 3D model, when we talked about the different things that go into it, one of the things is the mesh, and it's typically a binary representation of the the geometry of the object that you captured. And with something like GLB, I can go and use a different algorithm to create, let's say, just the mesh from the original the mesh that we had, and reduce it in size as much as I want. So here we've done it. We've brought it down to an 80% optimization. But let's say I want to make it even thinner. We have at Cloudinary, you have ways of taking that model and saying, okay, now give me something at 50% quality from the original model, and this happens dynamically. So you don't have to create multiple models at the same time. So that's pretty powerful. So for example, I'm going to drop this guy to 50. All right. So let's see, give it a second to, so what's happening behind the scenes is the meshes, that is with the model being analyzed, and, a new optimized mesh was created and replaced inside that same model. And here, I brought it down by another, what was it, like 8,000 or so in terms of the triangle count. But you can see that, with you start losing some of the detail here, as you can see. Or maybe I'm not sure if it's coming through on the screen here. In fact, we actually lost.
It is coming up. It is actually coming up, and we can see it. And what's important to understand here is that you're not involving your 3D modeling person, right? The end user is doing this, which is really a cool thing, right? Because now you're empowering the author, because they may not need 27,000 triangles, right, for displaying it on a small iPhone, let's say, on a small screen, right?
Exactly.
So you may not need all that detail. Yep, perfect.
Exactly.
Yep.
Cool. And just to kind of show a sense of what a wireframe looks like. So we talked about a mesh, and I had pictures there which were probably not all that interesting, but this is what a mesh looks like. And you can see that there's small little triangles here that have been captured to kind of give you the contour of a shoe, its lace up here, and so on. Cool. So with that, I wanted to then talk about what are the what does the future look like in terms of we have all these different formats and so on. So what do we think is going to happen next? For many of you that are old enough to remember this, it's like going back to the browser wars in the 90s, right? I mean, you had different browsers that had their own formats, or rather, had their own way of, for example, handling JavaScript, and so you had all these different variations back then. So We are in a similar state right now, but then with the advent of GLTF, we looked at GLB. Uh, they're going to be prominent because they're open standards, and as we saw, you can do a lot of interesting things with them. There's still going to be a place for some of the proprietary formats that we talked about earlier, because you still need to be able to kind of do that very rich set of work that you might want to do to create a 3D model. But these open formats are going to become more prominent, and eventually they'll catch up with with all the new features or new things that you could do within a 3D model and so on. The other interesting thing that's happening is, and this is just a favorite topic of mine, and we actually do spend a lot of time on thinking about this, here at Cloudinary, which is creating a 3D model is actually very, expensive. It could be very intensive work. You have studios, you have creators that use all the different tools, out there to create these models, and what is probably going to happen, or on its way of happening already, is just this, I like to call it democratization of the model creation process. So you have better cameras, you have depth sensors, and of course a bunch of AI on devices. So you do have examples out there where you could use your phone and then take a bunch of pictures of an object, let's say 10, 20, 30, whatever pictures from all different angles, and out comes a 3D model, which is, yeah, I mean, it's not going to be as good as something that a person actually went in and created and got it right, but it's good enough. And it serves as a starting point. You can take that and then clean it up wherever you need to clean it up. And so this is going to make that very that whole process very interesting. And so you will start seeing more 3D models just because of that. And also photography. So if you have a 3D model with all the lighting and all of that stuff well defined, and I'm sure some of you have seen, especially in the fashion space, you have all these try-ons and things like that, where the model is rich enough where I can actually try to put it on a body and kind of visualize it. Now with that, I can also just we talked about cameras earlier, right? So I can go and position my camera in the model wherever I want it, and then say, take me a picture of this. Essentially, what you get is a bitmap out of it. And so photography becomes very interesting when you think about it this way. Again, it's not going to be like very realistic, but the technology is getting there, where I could go from a 3D model and take pictures and videos out of that 3D model. And then the most interesting topic on everybody's mind, right? AR, VR, and then what about the metaverse? So different use cases require different things, and so what will most likely happen, these frameworks, these technologies, these ecosystems will all evolve. So you're going to have AR being used for things where AR makes sense. VR is going to be used for where VR makes sense. And for example, if you have Oculus and some of the games, it's very immersive. So gaming is a big area of, as far as VR is concerned. It could be pretty awesome. And then of course we're all talking about the metaverse. We'll see. I mean, is metaverse going to be something into which like a social network kind of morphs into? Those are to be seen. But the sense that I have is there's specific use cases, as we call them, where certain technologies, certain frameworks, for example, make sense, and so we'll probably see all of them kind of go into their natural places in terms of use cases that they kind of solve for and evolve from there. Cool. And so we talked hopefully this gives a bit of a background on 3D formats, what's happening behind the scenes, some of the important things that you need to consider while you're working with 3D, who's going to use it, how is it going to be delivered, and what am I going to build or do with that 3D model. I wanted to leave us with some of the tools that are out there. I spoke about Blender. It's free. You can go download it. You can create 3D models. Out of it, you can import other 3D models, and it's very popular with game developers who use this along with other things like Unity and stuff like that for the whole gaming piece of it. Talked about Maya, animations and very realistic kind of renders. People use Maya, and we talked about the format that it spits out. You can also use it, to convert like FBX to GLTF, and this is one of the paths that a lot of people take. Talked about phone-based scanners. I mean, there are apps out there which allow you to, if you want to play around with this, right? You could go and use some apps and take a picture of this mug. You can see that with the background that I have on my desk. And out comes a 3D model, which you can then stick it into Blender, which is free, and then kind of see what's happening behind the scenes. So that's pretty cool. What I showed you on the screen, in the Cloudinary DAM, where you could kind of change things around, it's all in the browser. So 3JS is a very popular JavaScript based framework. I would call it a framework because you can do a lot of things with it, or a library that you can use to kind of take that 3D model that you have and then show it on the screen, and then allow somebody to kind of play around with it on your phone even. We've actually created an AR kind of an experience called Web AR using 3JS. So it's some awesome work those people are doing out there. And then finally, we talked about optimization. So there are some specific libraries and I would call them toolkits, like libraries out there called Draco and Meshopt, which are used. Again, I'm thinking more about the production of the model is done. You've done the format conversions. Now you need to be able to deliver it, right, and do it effectively. So that is where these Draco and Meshopt come into play. They optimize the mesh. By the way, what I showed you on the screen earlier is our own algorithms to do that. But you do have some of these that are there, which are fairly good. And some of these things here, you could put all these things together, and then get a 3D based app, kind of going if you wanted to. So I hope that was useful, and gives you a sense of 3D, what it is, formats, how it's used, and just to kind of get a sense of what that space is, because sometimes it can seem a little bit overwhelming with all these different things out there, but it's pretty exciting.
It definitely is. Yeah, definitely is. I mean, you did a great job on this presentation. Thank you so much, people. There's all your contact information there. There is your email. Naveen, thank you so much. It was chock full of information, and definitely a lot of 3D knowledge you shared with us. So thank you so much. I really appreciate your time.
Thanks, Marcelo, and thanks everybody. Enjoy creating some 3D models and working with it. It's a lot of fun. Thanks.
Awesome. Thank you. And thanks to the rest of you for watching. Remember to continue your journey learning all about digital asset management systems by watching the next lesson. Also, remember, if you want to get your knowledge certification, make sure you use the study guide for this lesson, which you can find in the bonus section of this course. And as always, you can get a hold of me right there, Marcelo@headlesscreator.com. So until the next lesson, have a great one, everybody.